Welcome to video 8 in a series of introductory videos for SolidCAM. This video's topic is the 2D iMachining Toolpath. So iMachining is a proprietary technology from SolidCAM, and the 2D Toolpath, 2D iMachining Toolpath, it can be thought of as an optimized automatic pocketing toolpath. So I'll actually show you in this video how to program that. So to start, in your part definition, we actually need to provide information about the machine and the material for the purposes of the iMachining calculation. So you can see there's two pull-down menus, one for the machine and one for the material. SolidCAM does come with a default list of both machine and material, but I'll show you how to create the definitions yourself. So you click on Edit iMachining Database, and in this window, we can click on New. Let's just give it a quick name. And as soon as we open up a new slot in that list, you can see that we have the parameters we need to provide in regards to the machine. In this case, the max feed, the max speed, and the max horsepower, in this case in inch units. So RPM, inch per minute, and horsepower. You can get that information from your machine supplier. You can get that from your operations manual. You can even get that on the internet if you look up and do a search for the make and model of your machine. In the material database, it's a similar process. We'll go give it a name. And the highlighted area, again, is the only information we need to provide in inch units. In this case, the ultimate tensile strength of the material in PSI. Again, you can get that from your material supplier. You can get that from the internet. There's actually a website we say you can go to on this expert side called matweb.com. And at matweb.com, if you do a search for your material, you can search for it in this corner here, or you can even do a search here. And basically, all you need to provide is a bit of the information about your material. In this case, 1018 steel. If I continue on, I do a search for it, it'll bring up this list here. These are all the parameters. These are the data sheets that come up for that parameter. I'm just going to choose the first one here as an example. And what we're looking for here is the ultimate tensile strength. The ultimate tensile strength of 1018 steel is 63,800 PSI. Okay, so I take that value and I can return to my iMachining. And you see that I've actually done it already for my version of 1018 steel. Right here, the 63,800 PSI. So if we jump out of here, that's all we need to do in terms of the definition of iMachining. If I click the green check mark to confirm my definitions of my part, now I can actually add the 2D iMachining toolpath. We can do so by going up to either the Operations tab, looking under 2.5D category, the SolidCAM 2.5D category, or as you've seen in my videos, I like to go to the old way and just go Add Milling Operation, 2D iMachining. Okay. This Operation Manager workflow on the left side is the same for all our toolpaths. So once you see this, you know how to do all our toolpaths. Specifically here, we're going to do what we always do. We're going to start with the iRough operation. So this is the roughing toolpath in iMachining. We're going to choose New Geometry. And I'm going to decide to start with this top pocket. So I'm just going to choose my top edge there. You can see that with these blue lines, it's giving me the different options, different directions that my toolpath can go. So if you just follow that arrow as I click along, it gives me all the options I can follow either in the tangent or the constant Z direction. You've seen in video 5 how I do this with pocketing, and it's the same thing here. So I refer you to video 5 on how to do chain selection, or video 6 as well in the profile. So here I'm just going to go with my constant Z propagation to find the rest of my pocket. Click the green check mark. Again, workflow is exactly the same. I'm just going to look for the part or the tool I'm going to use, in this case, my 1/2 inch end mill. Now, iMachining took that machine definition, that material definition, and now the dimensions of my tool to calculate my feeds and speeds for me. So if I go to the Data tab, you'll see that the feeds and speeds have been calculated for me based off that combination of machine, material, and end mill. Okay, so if we jump ahead to levels, again, the levels work just like they did with the pocketing toolpath in video 5. I'm just going to choose the top face. And the bottom face of my pocket, we're going to use this step here because I did only choose the outside edge of that geometry. Let's go to Technology. Here's my wall and floor offset. Jump back to Technology Wizard. So for the iMachining toolpaths, they're unique in that they have the calculation of the feeds and speeds for you. And in this case, we can control the aggressiveness of that calculation using the Technology Wizard, which is the window we're looking at right now. Once again, let me just pull up my little pen. And you can see here, those feeds and speeds have been calculated for you. If I go through and regulate the machining level, you'll see that those feeds and speeds will actually increase. As I move the slider to the right, to the left, you'll see that the aggressiveness of that calculation increases or decreases the feed rate, as well as that representation there of the chip load, of the chip thickness, the red, also increases or decreases. So again, this is an automated toolpath. It's calculating those fusion speeds for you, but you do have a level of control over that calculation. In addition to that, you can see the step down is also calculated for you as well. So this pocket, it's decided to take it in 2 steps with a step down of 430 thou of a step down, which leads to an actual cutting point along the helical flute of 1.2 or 1.1, sorry. So the 1.1 is actually 1.1 points along that flute, constant contact with the cutting face. And that, it's always searching for that whole number. But again, as the user, you can take a certain level of control over that by clicking on user defined. And now we have a definition of either number of steps or the step down. So again, if we think it should have taken it in a single step, there we go, number of steps equals 1. It's going to take that in a full step. So if, whenever possible, it uses the depth of cut as the full flute length. So this is sort of more of a traditional 2D iMachining toolpath here as well, where it's trying to use the full flute length, but it has determined in its calculations to not be the most efficient use of this tool. So I'm going to switch it back to automatic, and let's do a save and calculate and see what that toolpath actually looks like. Okay, so if I exit that, and let's take a top view of that. So iMachining begins with that helical entry. You can see they're represented in the green. And from there, from that helix, it morphs out in what we call the morphing spiral to match the outside contour of the pocket. But as it goes along, when it gets to these corners, it actually feeds out rapids and retracts back to a cutting area where it can actually re-enter the part with a better cutting angle. It's always regulating the feed, the speed, and the cutting angle to make sure that it optimizes the tool path, in this case, in these sharp corners, to not bury the tool, to not overload the tool. Okay. In addition to that, if I kind of rotate around, you'll see that there's really only one entry and one exit, meaning that the tool is constantly aware of where the material that was just removed is, and it can actually skim across the surface so that it minimizes that retraction motion. Okay. So like I said, that is the iRough 2D iMachining toolpath. Let's actually make a save and copy of that. And let's apply it to the inside pocket, at the very bottom. So once again, I just choose my edge there. Constant Z propagation finds the rest of that pocket. And I'm actually going to add this island as well. So now it's going to machine between those two chains. We'll change my levels to start at the previous pocket's depth, and we'll go even deeper to the very bottom of the pocket. Technology Wizard, once again, it's letting us know it's going to take that in a single step. And really, there's only one way to do that because it is a very shallow pocket. So save and calculate. And let's take a look at that toolpath. So a little something different is going on here. Because there's an island, it can't exactly do that full morphing spiral that we saw with the previous toolpath. It actually needs to add this separation channel. And that way it can actually do a better job of doing the morphing spiral. You can see that there. Okay, once again, it does have the morphing, the helical entry, and it does have minimal retraction motions. So that is the iRough. Now, the thing is with iMachining, it recognized that it could not bury it cannot get its tool into that corner without burying the tool. So it actually left a bit of a cusp behind that this tool was too large to machine. So what we'd want to do is use a rest operation. So similar to what you saw in video 5 in terms of the rest material option, we have the same thing here in SolidCAM, but in the top left corner we call it iRest. What we can do here is choose a smaller tool, in this case, 1/4-inch tool. This 1/4-inch tool definitely will fit in those corners. I'm just going to rev this to level 8. And because it's iRest, under the iRest data, I made a save and copy of that previous toolpath, so it knows which one would be the parent operation. But if it didn't, I can switch this to user defined and then give it those parameters that are currently blacked out. But let's take a look at that. So let me just go back to technology and make sure that I choose corners only. If I had left it as is, it would actually machine the walls as well, meaning that it's looking to do something with this offset. If the offset wasn't the same as the previous one, then it would try and remove some material on the walls. But I'm only going to focus on the corners for now. So if I do another save and calculate, there we go. It noticed that it just needs to do a couple of sweeps along those corners to clean out those corners. So that is the iRest. There's also iFinish, which, as it sounds, is the finishing operation version of this 2D iMachining. So again, we're going to use the same geometry. We're going to use the same tool just for simplicity today. And I'm going to leave this as 0 on the walls. If I click on floor, it's actually new in 2016 where I can allow it to use either an iMachining toolpath or just a traditional looking contour toolpath. The iMachining toolpath versus the contour, the reason that option is now there is because the iMachining with all this tricoto movement and arc movements, it might not leave the best finish. If you're looking for that traditional race car track kind of finish, you're looking for the contour. Let's take a look at what this does. Okay, so it still uses the iMachining toolpath, the feeds and speed, on any of the walls, but on the floor, it actually uses the contour toolpath, which looks much nicer. Okay, so that's it for 2D iMachining. If you have any other questions, you can always call us at the main tech support line at 1-866-975-1115, extension 2, or you can stay tuned for the rest of the videos where we'll tackle the other toolpaths from SolidCAM. Thank you for watching.